Hello and welcome to setns.live, everyone. This week we're doing things a little bit differently. We're doing a little bit of a kind of a pre-game show. We have a good friend of mine, Victor, joining us all the way over from Spain. So here he is now. Hi, Victor. How are you?
Hi, Chris. Hi, everyone. For having me here. I'm
Yeah,
great. How are you?
I'm good. It's Friday. I'm exhausted from the week, but I'm happy. I'm happy to be here. I'm happy for a break, and next week we have a lot of exciting things coming up with Falco open source, and I have a keynote next week. So my goal for this weekend is just
Ooh.
to sleep, relax, try to enjoy myself, and get ready for an exciting week next week. I haven't actually given a conference presentation in a few months, so I'm kind of like remembering what it's like to get like that pre-talk, like you get a little nervous.
Is it much different than talking here on the live streams?
So I guess this is kind of the sentiment for everything right now, which is whenever I give a presentation like in front of people, it's like there's a lot of energy in the room, and like I myself I get into that headspace and I almost go into this uh like high adrenaline. I'm on stage, I'm in the moment, and then like right now you can't see, but there's actually maybe five or six stuffed animals on the ground in front of me, and that's my audience.
Oh, I have to do that because when I talk mostly on live streams, I don't know where to look at. I don't look to the camera. It looks so cold. You don't see the reactions of the people. And like you say, when you are giving a talk, you see the faces of the people, the surprise, the
Yeah.
approval. When something is weird and you have to re-explain, cues like that.
Yeah, it's different. So that's why I'm really enjoying doing set nests and having guests come on and keeping it kind of unscripted like this, where we just kind of get to have that natural moment. It brings back a lot of that in person vibe that I feel like we're all kind of missing right now. So thanks for joining us. Wait, was that a Pokemon Cup?
Yeah, it's from
Awesome.
Fire Pokemon.
Awesome. Okay,
Yeah.
so you work with me here at Sysdig and you have some updates for us this week.
Yay! So I think the last news that we had is IBM announced its computing services for their IBM cloud, and we Sysdig are part of it. So that's big news because cloud computing is going to be a huge deal from now on, and it's a very huge challenge because you have to scale a lot with cloud computing. So yeah, I will direct people to get the whole details on our blog, sysdig.com/blog. We have
Awesome.
a really nice content coming up and
So
interesting.
we usually do. We have like a. Have you ever used the tool HackMD before?
No.
So here, I know what you're seeing is about 10 seconds behind what we're actually talking about. But if I pull up Chrome here, I'll actually share this in the chat.
Oh,
For
that's nice.
HackMD, it's basically like a collaborative GitHub Markdown editor. So it's kind of like Google Docs, but for
Oh,
Markdown,
that's nice.
where like I can edit it
Oh,
and you can edit it. And this is what we use in the Falco community to take notes. And we can actually, I can put a link right here. And if you want to go in, I think you can just log in with GitHub, and you can just start typing notes here. So we can start putting these blogs that you're mentioning, so people can see them afterwards. And I can put a link to this HackMD when this video ends up on YouTube after we're done today.
cool. This is great. I'm logging in.
Cool. There you go.
Oh,
And if other folks want to add anything or take notes, or if they have questions or want to share something, that's a good place for people to share if you're joining and you would like to get involved. And so yeah, set an S. I guess Victor, I'm gonna take a stab at trying to explain to you what what started out as a weekly live stream, but is slowly turning into more of a community driven, I would say, network of live streaming that's going on in the world right now. If you follow along on Twitter, you'll notice our friends over at VMware, Joe and Duffy both tweeted about setns, and they do a weekly live stream as well every week that starts at 1 p.m., which should be starting right when we get done today. So I think we're kind of like naturally building this pipeline of, if you want to get the weekly what's new in cloud native, Linux, and open source, we have these back-to-back streams, which is pretty nice. And it says, Eddie Catflap says, that's awesome. First I'd heard of that. Awesome. Cool. So you added the link to the blog. Yes?
Hey. Added another one that we released this week.
Awesome.
It's not security related, but it's cool.
Nice. So this first one, we have Secure DevOps at the Edge with Sysdig and IBM. So this is really cool. I kind of want to get like an IBM cluster set up and running so I can start playing with a lot of it. A lot of that we're doing with IBM these days. I mean, we're basically, Sysdig Secure is basically the CloudWatch of IBM Cloud, right?
Yes, which is impressive because there are a lot of customers there, corporate customers, and they do need the scale. So, I mean, you are the CloudWatch of IBM. It's a huge scale, and we are able to take that, and people are happy with that. It's great to be there.
That's awesome.
Cool.
So at Sysdig, you and I really don't get to connect that much because you're usually ending your day when I'm waking up for the day. And so like we have the same set of constraints with working with the Italian team. But what are you like? What does a day in the life look like for you? What are you mostly working on? What tools are you getting to play with?
So currently on Sysdig, I have kind of a weird work job because I'm working on the blog. I'm mostly working on content for marketing, teaching, and working a little bit with the training guys. And it's mostly reviewing a lot of content and giving the small thoughts to make that is good quality content that we provide there. You probably know some of my articles. I'm in charge of the What's New in Kubernetes articles, which get a lot of views. They are the most successful by far. And
where would we go to find those What's New in Kubernetes articles? Can I just Google for it?
Yes, so probably if you find Kubernetes 118, I will be one of the first results.
Okay. Oh yeah, there you are, Víctor Jimenez.
Nice. That's me.
And so this is like a high level overview of everything that has released in Kubernetes since the previous release, which Kubernetes releases happen about every 3 months. This is cool.
Yeah, it's kind of interesting because, I mean, it's a great opportunity for me to learn a lot of Kubernetes. When you drill down into the weird features that not everyone uses and you get the details, I really like that. And the team does a great job making a lot of information on the progress and the enablement public. Their process is amazing. They have a GitHub just for that, to follow the process. And they have some spreadsheets where they put all the new features that are coming in, the documentation and everything. So you can go there and learn a lot. And we link to those on our articles to honor their job. We are basing on their job. And yeah, there are like 38 new features enhancements every release. That's not taking account some small bug fixes. It's kind of curious, the process they have. New features don't start as stable as you could expect because people have to test them. They start as alpha, and after some time they get into beta, and after they get tested, they get to stable. So at least 3 releases. And there are some features in 118 that are kind of weird, like they've been for months on alpha, like ingress or the API server proxy. And they've been in alpha for a long time, but they have become de facto features that everyone uses. And now in 118, they are taking a rethink of them and they are preparing them to go to stable, and they make them the proper tool that they should be. So it's kind of nice, this process.
Nice. Yeah, so I know there's been a lot of talk, if you follow around on Twitter, like you were talking about with the Kubernetes API, we have things that are in alpha, they later can graduate to beta, and then ultimately they can achieve the highest and most coveted status of all Kubernetes objects, GA, which it's usually quite exciting whenever a feature makes it to GA, because that shows deep maturity and adoption by the Kubernetes ecosystem. But contrary-wise, sometimes we do have to move things forward, and we do have to make breaking changes. So Kubernetes also has a concept of deprecating things. So I think the first phase is you just get a warning, and then that stays in for a few cycles. And as your workflow continues, you'll be warned that the feature you're using is potentially going to go away. And then ultimately, if you continue to upgrade, you would get to a situation where that feature you were using in the past no longer works here. And this is a fundamental problem with all computer science. I mean, this is like backwards compatibility at its finest. And you see tools like PHP, like Python, where they made the breaking change from Python 2 to Python 3, and at some point you just kind of have to do it, and that's what is happening here with the Kubernetes API. And I think Kubernetes is handling it really well when you look at the other ways we could potentially be making these deep, impactful changes.
I think one of the things that help this the most is the fact that they are doing these big releases that are not too big every 3 months. If they were waiting for 1 year or something like that, the changes will be more drastic and people will be more reluctant to upgrade. So that's great. And also, I think this is healthy for developers and the software development process in general, because you are forcing people to keep updating gradually. And that creates a culture of constantly upgrading that makes you able to react to those changes. Like I remember when I was doing iOS development and mobile apps, every year Apple released a new OS version, and you have to update your application to work on it, and you have to do it because your customers are going to upgrade it. And you were forced to do it. So in our team, we had this culture to once a year stop for a month and do this cleanup of everything to to continue. Sorry, I forgot how to English for a moment.
It's okay. So yeah, I mean, English as a second language for you, you're doing fantastically. I wish I was this fluent in the other language I'm trying to learn. So deep respect to you, Victor, for being able to do this. But yeah, we appreciate you coming and sharing, and that's cool that every Kubernetes release we get kind of a high level overview, and we get a single point, like a single source of truth for everything that's changed. Okay, and it looks like Allan is trying to join now. So on that note, let's maybe let him into the room, and we'll segue over. And thank you for joining us.
Cool, thank you. It's been great having been here. Bye, everyone. See you around.
Thanks, Victor. Bye.
Bye.
Hey, Allan.
Hello.
Nice to meet you.
How are you?
Face to face.
You too.
So we just let Victor hang up on us. He joined from Spain, and we were kind of given a quick 15-minute overview of what's new in the Kubernetes and containers world. But welcome to the show. We're happy to have you here, and I'm ready to start talking ZFS. I think that's why we're all here today.
Yeah.
So could you maybe share a little bit about yourself and your background and how you got to what I noticed on your Twitter page? It's you labeled yourself a ZFS expert. How did you get to such an elite status, sir?
Yeah. So I guess I started using FreeBSD about almost 20 years ago now. Just as a sysadmin, trying to do the regular stuff you do with a server, back in the very early 2000s and so on. Running actually an IRC hosting company was how I started.
That's awesome.
Yeah, and at the time it was, I did a little bake-off between FreeBSD and Slackware to decide which to put on the server, and I liked FreeBSD a lot better. The docs were better, and there weren't as many exploits for FreeBSD at the time. And I kind of went from there, but mostly just as a user, and not going much beyond just being a sysadmin and using FreeBSD for all of my own stuff. And then in 2012, I went to my first BSD conference. It was a BSDCan in Ottawa, and met a lot of interesting people and heard about this new interesting file system called ZFS. And I thought, wow, that sounds really interesting. And shortly after that, in my professional life, was also needing to stand up a big storage server to hold a lot of recorded live video streams, actually. And so I decided to use ZFS and start playing with it. And then when it came around to the BSD conference again the next year, so a year later, on the train to the conference, I started writing some documentation, just some basics of what I had learned and trying to improve what documentation FreeBSD had. Because what really annoyed me about the documentation FreeBSD had at the time was it started with this big, scary caveat about if you want to use this on a 32-bit computer, you need to custom compile your kernel with all these special settings and so on to try to deal with the fact that, the memory map on a 32-bit computer is limited to 4 gigabytes. And I'm like, that can go at the end. Like, most people don't need that, and that's just going to scare people away.
Yes.
And so I kind of started rewriting the documentation of it and putting the quick start stuff near the beginning instead. And at BSDCan, they have these events called doc sprints, where in the evenings of the conference, there's a room set aside somewhere with a bunch of people that do documentation available, and people who are new can just come in and get kind of one-on-one help on how to get started. And so when I showed up with a bunch of text I wrote on the train on the way to the conference, they helped me massage it and learn the markup and so on to make it the documentation. And I kind of kept going with that after the conference was over. And so when I came back the next year, I was officially inducted into the FreeBSD project and given a commit bit to write to the documentation repo.
Awesome.
And I kind of just went out of control from there. And then I
just lost it. Everything went wild and just FreeBSD all day, every day.
Basically, and by the next year, I had a commit bit for source, and was working on the installer and adding ZFS support to that. And then I worked on the bootloader and adding support for booting from full disk encryption encrypted disks that had ZFS on them, and making that work all from the bootloader so that you didn't have to have the kernel live on a not encrypted partition or something like that.
I see.
And then I got elected to the core team. So every 2 years, the FreeBSD community selects 9 people from the hundreds of committers to kind of be the leadership. And I'm just about to finish my second term of that.
Congratulations.
So it's been quite an adventure going from, I'm just here to write a few documents to, I've touched a lot of different bits of the code and got put in charge of stuff, even though I'm still quite new compared to, a lot of the people around me have been, FreeBSD committers for 20 years, not just users.
Wow. That's crazy. Yeah, it's always interesting to see how impactful a conference can be around an open source project. I think I've heard very similar stories of it all started, one afternoon at a conference, somebody walked up to me, and fast forward 10 years and here I am, I'm now a full-time maintainer of the project. But it's really powerful to have those experiences and realize that everything in open source, ultimately, like, you can be as involved as you would like to be. It's just about dedication and perseverance.
Yeah, well, and the other thing that I find with the conference is that it can kind of refresh your enthusiasm. Or we'd like to say, recharge your BSD battery. Because, when you're working by yourself, there's only so much feedback or whatever, and you're like, oh, well, I can get to that next weekend or something, or, it's just, I don't feel like working on that right now or whatever. But when you're around a bunch of other people and they're excited about it as well, it can just, reignite the flame.
That's awesome. Yeah, I definitely see that. So on my side of things, like, I guess to give a little bit of history on me and where I kind of fit into all of this, FreeBSD was one of the first Unix-based operating systems I really got into, and it was mostly just because, my friend down the street said, use FreeBSD and run Emacs, and that was kind of what the cool kids did, and that's where I started. And then, of course, moving into my professional career, FreeBSD became more of a hobby of mine, and Linux took over my 9 to 5. And then this whole container thing happened, and as I was learning about containers and Kubernetes, which most people here, that's probably where they know me from, of course, I always had this concept of, oh, this is like jails, but there's some fundamental differences here. And I'm interested to hear from you and your experience, how the file system was able to impact and drive the progression of jails, and how you start to separate out your concerns from an application level.
Yeah, so the basic concept of jails is you have basically a CH root with another copy of the operating system in it, maybe without the kernel part, and you can run it almost like a lightweight virtual machine. And that works. And then with ZFS, starting over a little, Solaris, where ZFS came from, saw the concept of jails and took that and went further with it and created what they called zones, which were even more developed version of jails. And so when they built ZFS, they decided that it should be a first-class citizen with this concept of zones. So it allows you to delegate one of the data sets. So when you have ZFS, you have one big pool of storage, and then you can create many virtual file systems on top of it that all share the free space, so that any one of them can use up the free space. You don't have the problems you normally did with partitioning, where, I made this partition too big and this one too small, and now I don't have space where I need it. ZFS solves that problem. But it allows you to delegate one of those virtual file systems into the jail or the zone, the container, so that root in the container now controls that and can create their own child data sets of that and file systems, and can control the mount points and all the settings and do whatever they want with it. Sure. But they only see that data set you delegated to them and anything below it. Whereas as the administrator on the host system, or the global zone in Solaris speak, sure, when you do ZFS list and get the list of the file systems, you see all of them that exist on the machine.
I see. So similar to the mount namespace in Linux, and basically being able to create, I'll call them storage namespaces because that's the vernacular we use. But in FreeBSD, we would just have ZFS as our underlying host volume.
Mm-hmm. Yeah, and then each of these file systems in that namespace has a bunch of properties that the root in the container can control, and a few that they can't. There's you can set a quota so that they can't use more than so much space, and you can also limit how many child data sets and snapshots they can create, so that they can't basically do a denial of service against the host machine by just creating 1 billion snapshots or something until you run out of space.
Oh, interesting. I never even considered that as an attack vector. Wow, that's pretty fascinating.
Yeah, I think that one came from Joyent because they were doing that type of thing and had to think it all out. And so that's very interesting. And then ZFS, both in the container concept or just on a single host machine, also has the concept of delegation to a user. So you can delegate specific permissions to a non-root user. So you can make a separate data set for each person's home directory and allow them to destroy their own snapshots, or a bunch of other permissions. So you can control, for example, if you use ZFS has a replication feature where you can serialize a file system into a stream you can send across the network, or even incremental between snapshots. You can make it so that a non-root user can do that. So your backup script doesn't have to run as root to be able to replicate your machine to the backup machine or whatever.
I see. That's really, really powerful. So,
yeah, or go ahead.
Oh no, I was gonna tell a little bit of the saga of how we ended up here and what insane path I was marching down, and ultimately ended up on your Twitter profile and found the courage to reach out to you and ask if you could join me. I work for a company called Sysdig, and we have an open source project called Falco. It's written in, the majority of it is written in C++, but we do interface directly with the Linux kernel, and that component is written in C. And we basically take runtime kernel events and we bubble those up to user space over a ring buffer. And then we have a rules engine that asserts this stream of events against a set of arbitrary rules. These are things like, did somebody do an exec CVE that we didn't know about? Or did somebody try to create a file in a well-known executable directory? Something happened on the network. And we get these deep kernel level events that we can write a higher level abstracted set of rules on top of. And one of the things that we were struggling with, I mean, one, open source projects in general are hard. Like you had mentioned, being elected to the FreeBSD. We call it a governing board in Kubernetes. Is it called in FreeBSD?
Just the core team.
The core team. But yeah, like there's a lot of like the human element with running an open source project. So I've been researching other open source tools that have sort of the same style of artifacts that we have in Falco. And naturally, I'll use ZFS to stick with your vernacular. Naturally, ZFS was a great example of it. We have a kernel module, we have user space utilities. It's an open source tool, and the install path of installing our software is fairly similar to the install path of installing OpenZFS. Download the tarball, compile the kernel module, load it into the kernel, and then you can start taking advantage of that kernel module's logic from user space using a set of utilities. And as I was going through that, I stumbled across ZFS, and then I noticed that the Linux community and the FreeBSD community were working together in concert, and it seemed like almost too good to be true. And so not only did I find this project that was doing a very elegant job at the install story that I was looking for a good example of, but even more so, here's a project that was able to span, in my mind, which is this is like Emacs versus Vim in my mind. FreeBSD versus Linux is a rivalry that goes pretty far back in my lifetime. And to see folks coming together was really, really inspirational for me as an open source engineer. Have you been a part of this effort to unite FreeBSD and Linux, or can you share any more about how that happened and what that's been like?
I was only kind of tangentially involved, but I was definitely in favor of it. So it kind of goes back to, I guess, 2013 or so, actually, when Oracle bought Sun and closed down the open sourcing of future updates to ZFS. But at the time, there was the open source, or I guess shortly after that, they forked the last open source version of OpenSolaris and created the Illumos project, which is basically was the upstream of truth for ZFS for a long time. And so, but to try to avoid, what ZFS is from diverging too much, especially, we always had the goal of we want to be able to have a file system that you can, create on a Linux machine and then import on a FreeBSD machine and then move it to an Illumos machine. And if you know ZFS, you'll know it on all these operating systems and things won't be different. And so Matt Ahrens, who was one of the original authors of ZFS, created the OpenZFS project. And the goal was to try to keep ZFS common between all the different operating systems, which at the time it had been ported to FreeBSD, Linux, and Mac, plus the original Solaris. And the idea was to try to keep these as common as possible. And the original idea was to have this common repo that would contain all of the code that was the same across all of the different operating systems. Yeah. And that would be able to be compiled in user space for testing. And then each OS would then pull that down, add all their integration glue to hook up to their kernel that might be different in their VFS layer and so on, and build it like that. The problem came to that nobody had a commercial incentive to maintain the kind of agnostic version. This user space only version that didn't have any OS glue in it at all, because it was going to be a bunch of work and there was no business case for it. So nobody was going to sponsor keeping this kind of one common repo thing going. So it kind of ended up that we had, on GitHub, there was a repo called OpenZFS, and it was a fork of Illumos. And then, FreeBSD would pull changes down from that into their repo and clean them up, and then Linux was doing the same. But in both those cases, FreeBSD and Linux were also adding their own new features, and they were available for people to pull over, and sometimes we'd try to upstream them, but it wasn't always, fixing a small bug didn't necessarily notify the other implementations of ZFS that, hey, you might want to check and make sure you don't have this bug too.
Yeah.
And it would lead to, oh, we found this bug, and it turns out somebody else fixed it 4 years ago, and we just never heard about it. And we kind of wanted to make sure that kind of thing didn't happen anymore.
I see.
And at the time, the ZFS on Linux repo had kind of had the most recent activity, more changes going into it than to other repos. So when we decided to try to sync that up in FreeBSD, it made sense to basically report that newer version to FreeBSD, because even on Linux, they use what they call the Solaris porting layer. So a lot of the code in ZFS uses a Solaris type API, and then there's on Linux the SPL, or on FreeBSD we call it the Open Solaris compat, and it translates those to the OS specific functions for doing things like allocating memory or starting threads and so on.
It's so interesting. We've had to solve these exact same problems in Kubernetes and containers, but at the layer of the system is different, but the pattern behind the problems are exactly the same. For instance, we have Kubernetes, which aims to basically be a kernel for the cloud. We needed to represent, just like the same way that the FreeBSD kernel and the same way that the Linux kernel represents hardware, we had to represent various components in the cloud in an agnostic way. And then we have what we call cloud providers, which is just like the glue that says, you call it a virtual machine in the higher level API, or we'll call it a server or something. And then that actually directly concretely translates to, an EC2 instance or a virtual machine in Azure or whatever it happens to be. But having the shared logic, for me in my history, has been really hard to get that abstraction right. And I've always had like a problem where you always end up catching yourself trying to bake in features for operating system specific components at that abstraction layer as well. Have you ran into, like, one, have you found an elegant way to solve that? Or two, have there been any notable cases where you had to make exceptions to the rule there?
Yeah, so our biggest fear when we were trying to combine the Linux and FreeBSD code was to we wanted to avoid having files that have giant blocks of, if def Linux do this, else if def FreeBSD do that kind of thing. And there was already a bit of that in FreeBSD, because we had, the Illumos code, which we'd pull in from their repo, and then we'd have little bits where say, this is FreeBSD, so do it this way. But we would keep the Illumos code so that we would notice when they change something that we might have to, port that change to the FreeBSD version of it. What they decided to do that I think works much better in this new OpenZFS 2.0 repo is they have subdirectories for each operating system. So there's module ZFS, and then it has all the code that's common to just ZFS itself. And then if, for example, the part where you actually talk to the disk, the block device layer is different on Linux than it is on FreeBSD. And so there's OS FreeBSD, and then a file that has the functions for that, and then one for Linux. And so just the make file just grabs the right one of those and plugs it in. And now you have ZFS compiled to talk to whatever the interface is for your operating system.
That's really cool. How do you go? Go ahead.
There's also work in progress to add the OSX port of ZFS to this repo. So ideally, over time, that repo will support at least 4 different operating systems.
That's so beautiful.
Not just
That's
2.
so cool.
Yeah, right now, a lot of it is because the original code was written for Solaris. It's the Solaris APIs, and then we just adapted them. But going forward, we might actually just make a slightly more generic, ZFS API that each operating system has to implement this primitive kind of thing, instead of using whatever the Solaris equivalent is, because when we're developing new code, there might not be a Solaris equivalent quite the same.
So my question here is around tracking backwards compatibility for what I'm going to call, and please keep me honest here and correct me if I'm using the wrong words here, what I'm going to call the ZFS API. In Kubernetes, one of the things that we had to do is we had to come up with a way of making changes over time, of having a concept of alpha, beta, and GA level features, And as those changed over time, we would ultimately have to deprecate older things. And we put together, we call it API machinery, but it's basically a set of tools that do the translation between what used to be called function A is now a combination of calling functions B and C, but there's still code in existence that calls A that needs to get translated to two function calls for B and C now. Has that been an architectural challenge for the ZFS community, and how have you gone about solving those types of problems?
Yes and no. Part of it is that generally you have the kernel module and the user space that are talking to each other are the same version, so you don't have to have quite as much compatibility. Although in FreeBSD, we do support handling, you have a newer kernel but an older user space. And although in most of those cases, it's actually the IOCTL has changed. The arguments have changed or whatever. And we have this backwards compatibility bits to make it still work.
I see.
The other thing, so originally when ZFS was controlled by Sun, they had just version numbers that just went up. So right, we had version up to 28, and then that's when they stopped being open source. When they started the Open ZFS project, they needed a different solution because features could be added to different operating systems in different orders. Right, like a feature developed on Linux will go into Linux first, and at the same time another feature is being developed on FreeBSD, and they both couldn't be called version 29. And having the versions not be in order didn't make sense. So they came up with this concept of feature flags. So we just arbitrarily set the version number to 5,000 and don't change it anymore, and have a flag for each feature. And features can also be, a feature can be enabled but not active, meaning that your system supports it, but it's not in use. So it's still backwards compatible with a machine that doesn't understand that. But once you use the feature, it's not backwards compatible anymore. But if you delete the last thing that was using the feature, then it goes back to being compatible.
I see. Interesting. Yeah, it always fascinates me how different projects at different levels of the stack end up solving the same problems, but for two completely different use cases.
Yeah, so ZFS has got a little bit of a problem in the API we expose to tools outside of ZFS itself. So there's two different libraries. There's libzfs, which is not a stable API. It will break between versions. And then there's libzfs core, which is a more basic, and it exposes all the basic functionalities you would get from the command line tools, and makes it easy for you to write your program. And we promise those aren't going to change out from underneath you. And they will have that kind of adapter layer or backwards compatibility like you talked about. But the core library itself, you need to build your program against the version of ZFS you're using for it to work.
I see.
Maybe someday we can get a stable one, but right now we didn't want to limit our flexibility and have to carry around a lot of backwards compatibility when there's currently not that much stuff that's actually needing to integrate with the file system at that level. It's a slightly different use case and something like the tool you're talking about.
I see. So ZFS core is to libzfs as, let's say, glibc is to the arbitrary libraries that a user would use.
Yeah, something kind of like that, where it provides all the basic functionality you need in a stable way, but maybe you don't quite get all the more advanced stuff yet because we want that to stay stable.
I see. Fascinating stuff here. So I don't want to put you on the spot, so feel free if you don't want to do this. But I would love to be able to show a lot of folks who are, if they're not here in the chat joining now, they're potentially going to be watching this on YouTube afterwards, maybe over the weekend. A lot of folks who will be watching this come from the ephemeral container world, where we do have different namespaces for network, for mount, for CPU, just like you see in FreeBSD. But the paradigm behind a container is very much, it's a stateless entity, it's short-lived, and it kind of runs, and you shouldn't really ever be interfacing directly with the container itself. It sort of has this application paradigm, similar to like a process would be on a Unix-like operating system. Whereas when I think of jails, I think persistent, I think secure, I think this is a feature, like you said, you treat into something that administrators can use to basically segregate out their systems for different use cases. I hear multi-tenancy, and all of these come with this concept of a jail being this longer-lived, I'll use the word like a pet that you would use and you would babysit over time. Would you feel comfortable showing us kind of like the easy 101 guide of ZFS on a FreeBSD-like system, and we can talk about how that compares to containers?
I could try. So jails can be ephemeral. Like, for example, the package building system we use to build the official binary packages for FreeBSD builds each different application in its own jail. So it starts up one jail for each CPU and starts building a different program in each one. And then when it's done, it just extracts the artifact that you got out of that, the compiled package, and puts it in its repo, and then deletes the jail and creates a new one. And then it installs any of the dependencies you needed, and then compiles the next thing. And these jails are set up so they don't even have access to the internet, so that we get no leaked dependencies or anything. Each program is compiled in a completely clean environment with only its dependencies available. And those jails last for sometimes only a few seconds. Or you can treat them like your long-running VM, like if it was a VMware or something, where I have this jail that's been running for 3 years, and it's it's as if it was a piece of hardware.
I see. And we have that same concept with building containers of, now we have like multi-stage container builds where you'll download the tool chain and everything you need, compile your software. This is what we do with Falco, with our kernel module. Download it. At that point, at runtime, the container instance itself is substantially large. It's got a lot on there. There's the object files. There's a lot left over from the compiling process. And there's a lot of the dependencies there as well. And then we basically take only what is needed and create a new container and just port over just the minimal amount of necessary application bits. So it sounds like Jails is doing a similar thing with how you're setting up different parts of the system. Cool.
Yeah, you can do it that way. Well, the really interesting thing about the way the kind of equivalent of namespaces works in FreeBSD with jails is that they work kind of like that two-way mirror you see on police shows. If you're on the host system, you can look into each of the jails and see what's going on, but they can't see out.
So that's kind of how the PID namespace works in Linux. Like if you share the PID1 namespace, which as a security engineer, this is one of my favorite, we'll use the word features of the Linux kernel. It kind of works the same way, whereas if you have that shared namespace, you can go up back to the host namespace for processes. But if it's not shared, then the host can see the child, but the child effectively believes they're the only thing in the universe at that point. Mm-hmm. Interesting.
Yeah, so it's very interesting to be able to kind of be able to look into the jail and see what's happening, but the jail can't look out. And so like on FreeBSD, the top utility has a filter where you can say, show me only processes from jail number 17 or whatever. Yeah. But when you're inside the jail, you can only see your processes and nothing else.
I see. Okay, so next question, and this is something we had to solve in container land over the past few years. So there's a couple of examples of running a container in a container. There's a project called Dend or Dined. There's one called Kind, Docker and Docker, Kubernetes and Docker, and all of the communication between the container process and the host daemon that's running, that's enabling all of these features, happens over a Unix domain socket. And then being able to port that domain socket sort of indefinitely, recursively into a container and a container and a container has allowed us to be able to build some pretty interesting topologies when it comes to containers. With ZFS and jails, can we do that same paradigm of recursive file systems? Can we have a ZFS jail inside of the ZFS jail?
So you can definitely have jails inside of jails. They're just called nested jails, and they're pretty interesting. I've never had that much of a use case for them, but I do know that they're there. I don't know if you can actually delegate a file system that's already been delegated into yet another jail. I've never actually tried that.
Interesting.
In general, you would be able to inherit it and use it as the CH root, but I don't know if you could give root in the inner jail, the control, yes, the jail within the jail, access to actually have administrative control over the file systems.
I see.
I'd have to try that. That's not something I've ever had a use case for, but it is an interesting idea.
I'm I'll agree. The word interesting comes to mind when I think of that. The use case that we have for it that got me thinking about asking this question was we have a tool called Kind, Kubernetes and Docker. And what's interesting is you would start a Kind cluster, and from the host system, my laptop that I'm working on, it looks like I have one container instance running. And then I can, exec into that container, and the namespaces are separated. I always see the process tree for the processes that I know about. The mount namespace is isolated, network is isolated. And then if I was to perform the exact same list on the container instances running in there, you would then see there's actually, it's one to many. Now there's many nested containers inside of the monolithic one running at, we'll say, layer 1. And then, of course, execing into all the layer 2 bits, that's where Kubernetes itself lives. So it gave us an ability to package up a lot of micro components into one broader deliverable, and then still run that with those same features from the kernel. But whenever I start having conversations around containers and containers and containers, I usually like to kind of evaluate whether or not that introducing so much complexity is going to be worth it. So I'm kind of torn between if it makes sense or if it doesn't. Yeah,
so I've looked at I sent you a link that you can put in your notes or whatever. So Dan Langill, who runs BSDCan, was wondering about running the package building process inside a jail, even though it has to be able to create 30 or more jails at a time. So it's constantly creating and destroying jails and getting it to work inside of a jail. And so he has some instructions on how it works. So that works, and it uses ZFS, although it optionally can avoid using ZFS, because one of the other things it does to save time when you're reusing those jails is it uses ZFS snapshot and rolls back to the snapshot. So instead of having to create the whole file system for each package, it can just create it, snapshot it, let you use it, and then erase your changes and get back to a clean slate in a fraction of a second, and then deploy the next one. So for that to work, it must be able to do ZFS from inside the jail. The only question is, can you actually sub-delegate a data set? And I'm not sure if that's possible.
Okay. Well, now you have my interest and gave me something to go look at to try to hack on this weekend. I was considering. I have some hardware I have a half rack in the other room, and I had been considering trying to set up a FreeNAS type environment with ZFS. And then, of course, finding you on Twitter, doing some research around the OpenZFS project. Now, and as a full-time Linux user, I was like, well, heck, if ZFS is now moving towards being more and more Linux compatible, I want to try to set up basically the Linux version of FreeNAS with ZFS. So I was able to get 0.8.3 running on Arch Linux with a hardened kernel. And the user experience with installing ZFS was, as a lifelong Unix lover and Unix user, was exactly what I would like to mirror. It was flawless, everything compiled right out of the box, the documentation was on point, and I would say within 5 minutes I was able to have my storage pool mounted and being able to list my Z pools, and it was a very, very, very excellent experience. So I was really happy with that.
So I don't think any of the container or delegation stuff works on Linux yet, but that's mostly just because someone's not wanted to spend the effort. I think there was some work on making it work with LXC or LXD or something a couple years ago. So every October or November, there's an OpenZFS Developer Summit conference. And somebody gave a talk about doing it on Linux, I think in 2016 or 2017. But I don't recall the details. But it'll be on the openZFS.org in the wiki if you go back to one of those conferences. There's somebody's talk about, at least a prototype of getting that kind of container delegation stuff working on Linux. And I think now that Ubuntu 20.04 is going to ship with ZFS support out of the box, that suddenly there might be a lot more interest in ZFS.
I was gonna bring that up. Other than this live stream, I have a less formal personal live stream that I'll kind of do after work or whatever, and everything from me playing video games to me setting up my crazy Raspberry Pi ARM projects. And we had somebody who works on the Ubuntu team at Canonical join, and I was setting up my ZFS cluster on Linux, and he was like, "Oh, you know that Ubuntu ships with it now. What do you think about that?" And I had been dying to ask you that question because ZFS in my mind has always just been like, this is the operating system of FreeBSD, or the file system of FreeBSD, and now like it's popping up in more places. Have you seen like an uptick in Linux interest or users or activity on the mailing list or anything after this has happened?
The Ubuntu stuff's still pretty new, but I'm expecting to see more. I do not try to ingest the fire hose of problem reports that come into the ZFS on Linux repo.
Okay.
Yeah, I have enough trouble keeping up with just the pull requests, people that actually have patches that we need to figure out, how to keep those going on FreeBSD and work on that. But yeah, I'm expecting to see a lot more of it, and I'm just really happy that we're going to have this file system that will just work across all the operating systems I might want to run. Jürgen Lundman is a bit crazy and managed to get it to work on Windows.
Oh wow.
So there's you can run ZFS on Windows 10, and it can read and write and send and receive, and is basically fully compatible with the version that you would run from Linux or BSD. And so you can make a USB stick that you can move back and forth between all of them, and it's really nice. The Windows one is still very alpha quality and so on, and lots of debugging in it and so on. But just the proof of concept that he was able to make it work as just a very small open source project. It's like him and a couple contributors.
That's really cool. Yeah, Windows support is always like an exciting time for any open source project. Before you joined the call, Victor was showing us the release notes for Kubernetes 1.18, and one of the highlights there was like more support for Windows, and I feel like that's like the sign of true adoption. Whenever you find folks who are adopting it so well, they're willing to take it to the next level and build on top of the internals of Windows. So that's like a big milestone for an open source project. I feel like that's really rad.
Yeah, and it also shows that you've how easy it is to port to Windows can show whether you've built your OS abstractions nice enough that they can deal with something that's very different, not just Unix different, but not Unix different.
Yeah, that's one of the things that we're slowly realizing in Falco right now is we have a concept of we call them drivers, and obviously I talked about the kernel module, which follows almost the exact same paradigm as OpenZFS running on Linux. But we also have a BPF probe that attempts to do the same thing. And the solution we came up with was just having a standardized interface and then having the kernel module specific code actually get loaded into the kernel at runtime, whereas BPF is a different type of implementation but delivers effectively the same style messages. And now we're working on a third one that is going to be built around ptrace, so that we're not even interacting with the kernel directly anymore, and we're going through the ptrace abstraction. But getting that interface right has been very hard for us in getting those functions defined and understood. It's not easy to do. So seeing that ZFS was able to do that with Windows is really inspiring. What is the that interface called in ZFS? Does that have a formal name?
Well, mostly it's the Solaris porting layer, because it's basically all the code in ZFS assumes you're running on Solaris, and then we have the porting layer that translates that to whatever you're actually running.
I see.
And the Windows port is definitely not perfect there. Like it just allocates a giant chunk of memory and then uses a Solaris style memory allocator in it, because dealing with all the differences in the way Windows deals with memory was a very big roadblock, and it was much quicker to get it working to just say, we're going to use the Solaris slab allocator on a big chunk of memory instead.
Yeah, absolutely. So can you tell us anything about distributing ZFS horizontally across different machines? One of my good friends is looking at doing some research on distributed file systems right now, and she's been looking at GlusterFS, SSHFS, a few other ways, NFS, a few other ways, iSCSI to distribute. Does ZFS have any first-class features that enable that, or is it still bound to just one machine?
Yeah, it's not really set up to be a distributed file system. It does have a feature, blanking on what it's called now. multi MMP. It has a feature so that if you have two machines that are connected to one JBUD that has all the disks in it, it has an extra set of checks to try to make sure you don't import the disks on both machines at the same time. So that's just for like hardware HA. So you can have two heads on one set of disks, and that way, if one has a hardware failure or whatever, you can use the other, and make sure that you don't trash the pool by having it imported on two different computers at once. But that's about the extent of it. But if you apply something like LusterFS or Gluster or Ceph, and then at the top layer, providing the distributed system, and then have it use ZFS to actually store the data, then it can work out pretty nice. Like the main reason why there is a very good port of ZFS to Linux was Lawrence Livermore National Labs needed to build a giant LusterFS distributed file system. I think they have like hundreds of machines. And so they took a version of Lustre that talks directly to ZFS at its data management unit layer. So it doesn't actually, it's not Lustre on top of ZFS, the file system. It's Lustre using ZFS as an object store directly. And so they built that, and originally didn't even support, mounting a file system in the POSIX way. But that got rounded out when there was more and more interest in it. And now ZFS on Linux is a very first-class port of ZFS. But it started out as just, we want to use ZFS as the object store for our giant Lustre distributed file system.
Cool. Yeah, I see. And that's
you're getting all the durability from ZFS, and then just using Lustre to expose this one giant virtual file system for whatever science they're doing at Lawrence Livermore.
Awesome. I see. So my approach here was not to use Gluster, but to basically use SSHFS to solve the network compatibility issue, where if I'm on one machine, how do I access my storage pool that's sitting in my rack over across town? So I guess that's really powerful for folks to start looking at, because what you don't know is there's been a number of folks who've reached out to me about ZFS and Kubernetes, ZFS in the cloud, because of the ability to have dynamic instances and to be able to resize them. And so I think, one of the first questions people always had was, how do we go about, data resiliency? How do we back it up? And my answer, of course, was, well, with ZFS, that's the whole point. You have the resiliency at the physical volume layer. But now hearing that,
and the backups are built in with the replication features, and being able to do an incremental replication without having to do something like rsync, where you have to crawl all the metadata and be like, did this file change or not? You just know exactly which blocks are different between this time in this point in time and that point in time, and you can just stream them at as fast as your network will go.
That's really awesome. Yeah, so you're getting that data back up at the physical volume layer, and your network is just managing what I would call like the user space feature of trying to make that feel as seamless and horizontal as possible. That's really cool. So how does ZFS go about doing the replication then? So if I'm a user space program and I try to write, let's say, a kilobyte to disk on a ZFS file system, when does the replication start, and what does that process at runtime look like?
Right. So the replication is always asynchronous, so it's not happening in real time. Okay. But so if you overwrite 1 kilobyte of an existing file, ZFS, because it's copy on write, it will not actually overwrite the block that's already on disk. It will allocate a new block and write your data there. Then depending on the record size, it might actually end up being more than 1 kilobyte of data that gets written. Normally you'd have like a 4K sector on the hard drive as the minimum, or there might be 128K block size on that file. So it'll write the new block over here, and part of the metadata that exists for that block is its birth time, which is basically which transaction group did this block come to be in. And then over time you can create ZFS snapshots.
Okay.
On my home machine, one gets created every 10 minutes, and then I keep the 10-minute interval for a couple of hours, and then I keep twice a day for a couple of months, and then a kind of typical backup grandfathering type scheme there. And then when I want to do replication, I can just run the command ZFS send, and I say incrementally everything between this snapshot and that snapshot. And once it knows those two snapshots, it knows the range of changes it wants. So then it finds any blocks that were born in that range of time, and then starts serializing them into this stream format that it can send across the network. What's really interesting about the way ZFS send works is that it is completely unidirectional. So there's no two-way communication. It's just writing out to the pipe of the ZFS send process. So you can just redirect that into a file and then keep it for a couple of years and use it later by piping it into ZFS receive, or you can write it to a tape, or you can pipe it over SSH, or any huge possible combinations of things.
Awesome.
And because it's unidirectional, the one downside is you have to tell it which features you want to use, because by default it will be the most backwards compatible. So it'll work with ZFS from 15 years ago.
Oh, wow.
By default. Whereas there's extra flags you can add. You can oh, we have compression now. So if the block was compressed on disk, don't uncompress it and then send it across the network. Leave it compressed. That'll be better. Because before, one of the most common workflows was literally take the ZFS send and then pipe it into gzip or something. And so you're reading compressed data from the disk, decompressing it, and then writing it into a compressor, which seemed like a bit of a waste.
Yeah.
And it made the process slower. And then now that encryption is built into ZFS, you can say, send the encrypted data across, and then the receiving system doesn't even need to have the decryption key. So this makes it really nice for remote backups, where the remote backup can have all the data, but none of the keys, and then you can restore it and then provide the key. And the remote backup site, which might be another company or something you don't trust, never has to have access to the keys at all.
They have access to the encrypted data only. I see.
Yes.
What does ZFS use for encryption?
It's AES GCM, because then you also get a message authentication code. So the way ZFS did it is it split. Normally, ZFS has a 256-bit checksum for every object or block of an object. So it defaults to Fletcher 4, but you can use SHA-512 or whatever. So that when it reads data from the disk, it can use the checksum to make sure the data hasn't been modified in some way. Mostly, that the hard drive hasn't given you back the wrong sector or corrupted data. So every time ZFS reads something from disk, it verifies the checksum to make sure it's actually the data that it wrote to the disk, which can be really helpful. Especially in the case where you have a mirror, right? So you have two disks that are supposed to be identical, and you've just read, if one of them dies and you're doing a resilver, if it turns out that the first disk was actually corrupt in that sector, but you don't know it, now you've replicated that error to the replacement disk, and now both disks are wrong, and you have no way to tell. So with ZFS, because you have this checksum, every time we read a block, we check its checksum and know. And so if we have two sides of a mirror and they both have different values for a certain sector, we can use the checksum to figure out which one's right and then correct the one that's wrong, instead of being I'm not sure which one of these is right.
Yes. The man with two watches, right?
Yeah, exactly. And so when you enable encryption, it actually splits that checksum in two. And the first half of it stays a checksum of the data that will be on disk, the encrypted version. But the other half is that message authentication code. So it's a way to prove that the plain text, once it's decrypted, you can prove that it hasn't been modified or maliciously messed with.
I see.
Because we store both of those, it means that on the system that, say, is holding the encrypted data but doesn't have any of the encryption keys available, you can still, if you have a failed disk, you can still replace it and do the resolver process, because it can still use the half of the checksum of the encrypted version to make sure the data is right, without ever having to have the encryption key. Whereas some other encrypted file systems, if you want to replace a disk or something, you need to load the encryption keys to do that. But all the administrative options in ZFS don't need the encryption key this way, so that data can actually be safe at rest the whole time.
Beautiful. I love it. That's such a clean solution, and for a lot of, in my industry, kernel security and Linux security, the majority of the conversations we have with folks is, but who has the keys to the kingdom? Where does this go, and then what do you need to use them for? And those conversations rarely end well. Usually we end up walking down a conversation around, okay, so let's work at how we abstract this and how do we manage these keys and where do we store the secrets and so on. And we've struggled with this in Kubernetes as well, which is a completely different story for a different day. But it's really nice to see that this is baked in at the file system level and not kind of running on top of a user land trying to prevent a lot of this from happening underneath. So that's really cool.
Yeah, because the other interesting one is like when you have a file server, lots of places have some kind of requirement of having encryption. But if you just have regular full disk encryption, even like with FreeBSD with Geli or Linux with Lux or whatever, as soon as you've mounted that file system, you've loaded the encryption key and all of the files are accessible as if they weren't encrypted.
Right.
So unless the attack is of the physical hardware after it's powered off, the encryption isn't actually protecting anything.
Right. Unless somebody walks into your data center, steals a hard drive and takes it home and plugs it in and tries to see what's on your hard drive, like it's still at runtime from the user's perspective unencrypted data.
Yeah, and so the only use case you really hear for it is, so if a drive fails, we can send it back to the manufacturer to get the replacement. It's like, well, if you're that worried about security, you can pay a little bit extra for the hard drives and they will just not ask for the old one back.
Yeah, that's
but
true.
it doesn't. So with ZFS, because each virtual file system you create can have different encryption keys and can be unloaded when you're not using it. So you can actually have a file server like your NAS, and you can say, all right, this data set here, this file system is my taxes. I don't need that mounted 24/7. I need it when I'm doing my taxes or when I'm trying to look up something for my taxes.
Sure.
So you can unmount it and unload the key, and now that data is at rest, while the rest of the data on your system, whether it's encrypted or not, can still be accessible.
Yeah.
But you can, because you have that option of administratively subdividing your disk into many file systems that each have different properties and can have different encryption keys, you can also make each one a separate kind of domain and say, those ones don't need to be online right now.
Awesome.
Or like, at my company, the data set that has all the customers' credit cards in it is only mounted when we're doing billing, which is usually only once a month. And the rest of the time, that data is offline and nobody can see it. And it just, makes it that much easier to sleep at night.
So, being that you can encrypt and decrypt data sets or subsets of your data, does that mean that, following the analogy we used earlier, talking about storage like the PIN namespace in Linux, does that mean that the data at the host level can have a different encryption key than the data within a jail, potentially?
Yeah, so each subtree can have its what we call the encryption root. But yeah, so for example, if you make a separate data set for a container and are giving that over to the owner of the container, then yes, they can have a completely separate encryption key, and maybe they could load it themselves or whatever. Although if it's running on in the container, because of the way it works, the host still has some access there, so it doesn't completely eliminate everything. But yes, it would let you have a different encryption key for each container, so that tenants couldn't mess with each other. But you still have the problem of, as a tenant, you still have to trust the host.
Yeah. Now, does the raw encrypted data, do those stack as you drill down into a jail instance? In other words, if I'm in a jail and I have encrypted data that's running from a data set that's shared from a previously encrypted data pool, I potentially would need both encryption keys in order to access my data. Or are these unique to each of the instances? Does that make sense?
So they kind of, in ZFS, it works at the clone family level.
Okay.
So when you create an encrypted data set, it and everything that ever gets created under it have one master key that doesn't ever change, because you don't want to have to re-encrypt all the data. So they have one randomly generated master key that is then protected with your user key, which is the password or key file that you provide. So you can change the password, but that doesn't actually change the master key that's used for the encryption, because that would require rewriting all the data, and that's not really a thing you can do easily, and that would take up a lot of space because of snapshots and so on.
Yeah. Okay. I see.
Because actually that came up as a possible problem when Ubuntu was working on their installer originally. They had thought about encrypting, as part of the installer, they would create the system image encrypted with a default password, and then at the end of the installer prompt you for a new password to change it to. But the problem with that is it means that because it's the same master key, someone could have accessed it earlier and got the master key and be able to read your data.
I see.
Whereas you want to make sure that you don't want to make every Ubuntu install start with the same master key.
Yeah, that seems a bit worrisome.
Yeah, but that didn't happen, so it's okay.
Okay, that's good. But with the new ZFS support in Ubuntu, it's more than just, hey, you can apt-get install ZFS now. Like, you can actually install the Ubuntu operating system components on a ZFS volume.
Yeah, and the big feature that I think they were after there was this feature from Solaris called boot environments. So for example, on my system, I have a ZFS dataset that's mounted as my / partition. And when I do an OS upgrade, the first thing I do is snapshot that. And then I clone that snapshot to make basically another writable file system with a different name. And then I do the upgrade. And then in the bootloader, in FreeBSD, it's automated. In Grub, you have to make a list, I think, but there's some support for it in Grub as well, where I get a list of these different boot environments. So I have, before upgrade on May 8th, and then the May 8th image. And so if I reboot after the upgrade and I run it and it doesn't quite work, I can just reboot again and select the older snapshot of the file system as my root partition. And when I reboot, I'll be back to how the system was before. But because my home directory is a separate file system, it doesn't go backwards in time.
I see. Oh, wow. So yeah, so we're now like at the operating system layer, we're kind of able to mix and match different components in the same way that the overlay file system works in containers, which is, you can actually separate down the operating system away from the application components. But in your example, it's your home directory. That's really, really cool.
Other things like your log files don't have to go backwards in time and so on. So I'd love this on my laptop for like going to conferences, because before the worst thing you could possibly do is upgrade your OS the week before you have to go present off that laptop. Because what if something breaks, especially in like X or some, you're upgrading 150 packages. Who knows which one's going to cause some other thing to not work properly? And it's always the stealth one, right? It's not that your laptop doesn't boot. It's that when you hook it up to the projector, it won't resize to the right screen size or whatever. Being able to just reboot, select the image from a week ago, but your home directory still has the new versions of your slides, not the old version of your slides from a week ago. It's just super handy.
Yeah.
And so Ubuntu has this built in now, so that you can basically, if something goes wrong, you can undo it, but you're undoing it in a way that doesn't destroy the newer version. It just lets you go, kind of time travel. And because these are what are called clones in ZFS, they're copy on write. So when you installed the update, only having both copies, the before and after, only takes the additional space of the files that changed. Right?
So it's like how commits work with Git. It's just measuring the delta. It's not actually rewriting the data in its entirety.
Yeah, so if you have a snapshot, so basically, because ZFS is copy on write, every time you change something, it writes it to a new spot, not over top of the original. And then if you have no snapshots, the original space becomes free. But if you have a snapshot, it's like, oh, somebody's still using that, I'll keep it. So you only lose the storage of the delta, and then you can later destroy the snapshot or whatever. But it allows you to have both copies. And it's also very useful for like if you have a big web application and you're like, all right, we need to do a schema upgrade. Or we're going to install the newer version of this application, or the next version of the database server or whatever. You can do it on a clone of it and make sure it works first.
Yeah.
It makes science experiments much easier to do when you say, all right, I have this 8 terabytes of data over here. I'd like a copy of that won't mess up the original, but I don't necessarily want to have to wait for 8 terabytes to copy or have to have 8 terabytes of more free space. Yeah. I can work on a copy of it and only use a couple hundred megs or gigs of space for my science experiment, and then get rid of it again, and not have had to copy 8 terabytes of data or wait for it to copy.
I see.
So clones can be very useful.
Yeah, I like how you use the word science experiment there. That's that was a big monumental paradigm shift in my career when I started looking at debugging and hacking and software engineering as science experiments, and realizing the importance of being able to replicate something. That now, after kind of learning that lesson the hard way, that's usually the very first thing I ever do when I'm approaching a technical problem is how do I replicate it and how do I ensure that I will continue to be able to replicate it moving forward. And it sounds like with ZFS, that's a first-class feature baked in at the kernel level, which is really cool. Okay, well, we're almost out of time. I'm having a ball just sitting here and nerding out with you and talking about ZFS and the kernel.
Yes, it's been fun.
But yeah, there are people here in the chat, so I'll let people, if they have any questions for Allan, feel free to ask, and we can check it out in the chat. If not, is there anything else that you would want to share? Maybe there's a place people can go to get involved, or mailing lists that you would suggest joining if they want to find out more.
Yeah, so if you're interested in ZFS and getting involved, it's the OpenZFS project on GitHub. It's now the home of the combined FreeBSD, Linux, and soon OS X version of ZFS. And there's the PRs and pull requests and stuff there. And the openZFS.org has a wiki with a lot of information, but obviously you could always use more. As far as getting involved, there's so many different ways. For me, I got started by working on what's called the FreeBSD Handbook, which is the official documentation for FreeBSD, and I just worked on the ZFS chapter. That chapter is kind of old now and missing a lot of the newer features. So if somebody wanted to just write down some stuff about some of the newer features, it's a nice way to get started. If you like talking about ZFS, I also do a weekly podcast called bsdnow.tv, and we have a question and answer segment at the end of the show, and there's usually at least one question about ZFS every week. So that's definitely worth checking out. And we also talk about any news or interesting things we find about ZFS in that show. And actually, the other podcast I do, 2.5admins.com, my co-host Jim Salter is big into ZFS on Linux and writes about it for Ars Technica.
I see. That's really cool. So 2.5admins.com?
Yeah, and bsdnow.tv. 2.5admins is only bi-weekly, but BSD Now is weekly.
And what day of the week, like what time do both of these happen?
So BSD Now is recorded live on Wednesdays and comes out on Thursdays. And the 2.5admins is recorded on Wednesday evenings and comes out whenever it's done being edited.
I see. Awesome. Anything else? Good references you would share? Anything else for viewers at home who aren't able to join us right now, but could potentially be watching this in the future?
If you want to get started with the basics of just using ZFS, Michael W. Lucas and I wrote a pair of books on it that you can buy on Amazon as an ebook or whatever. If you go to zfsbook.com, so it's FreeBSD Mastery ZFS and Advanced ZFS. Although at least 85% of all of that applies to Linux as well. Some of the very specific things about like how disk partitioning is done will be a little different on Linux, but hopefully next year we'll come out with second editions of those that are actually include everything for Linux and BSD.
I see. And I always know that I'm running out of time. The landscaping folks come in my neighborhood every Friday at 1 p.m. So that's usually when I start hearing the leaf blowers and the lawnmowers. It's a sign that we're almost out of time. But I think I've got all of the resources you shared here in this document, and I will, with your blessing, of course, put this on YouTube afterwards, and I will make sure to share the notes that we took if folks want to find out more. And I guess I'll make it a point. I'll add your Twitter, and I'll send you over a link as soon as everything is published.
Cool. Yes, and yes, my Twitter is probably the best way if people want to ask me random questions.
Yeah, I mean I just on a whim, and so you were actually the first time I've done this, like just completely cold called someone like this before. I've had a lot of people do it to me. And I think I've learned a lot about how intimidating it can be just randomly just message someone. So thank you for being warm and being welcoming and joining the show. I really appreciate it.
Yes, thanks for inviting me.
Yeah, cool. All right. And on that note, I will cut to the end scene here, and we will see everyone next time. Thanks again, Allan.
Thank you.
Bye.
Bye.